So number 10 shocked me a little bit because we haven't talked about what the derivative.
Excuse the interruption. Abby Ogan, Caitlin Kamek, or Michaela Phillips, you have left stuff in the teen center from singing this morning, and you need to get that before he locks out. Thank you.
All right, take 2. We haven't yet discussed, McKenna, what the derivative of e to the x is. So let's just go ahead and do that now real quick. These are the solutions to the 4.3 homework. So if I have the square root, need to get my program running here. Take 3. If I have the square root of y minus e to the x equals 2, how do I differentiate the square root of y? Yeah, it's y to the 1/2, so that becomes 1/2 y to the negative 1/2. Okay, so you did that, and what's left? dy dx, right? What rule of differentiation? Chain rule.
Okay.
Chain rule. Take the derivative of the square root first, and then after you've done that, the derivative of y with respect to x. Now it turns out that the derivative of e to the x, drum roll please, is e to the x.
Derivative of e to the x is e to the x.
Correct. It's a very, and actually now that I've told you that, later in the lesson I'll get to tell you a very corny math joke. So equals 0. And now we solve for good old dy dx. So we add e to the x to the other side. So we have 1/2, and I'll write it the way McKenna had it, 1 over 2 square roots of y dy dx equals e to the x. And then we multiply the 2 square roots of y up to the other side, and we get that dy dx equals 2 square roots of y e to the x. And there's your dy dx. Oh, this right here. Now let's go back to the instructions. What are they asking us to do here? Let's see. Find dy dx. Done. Solve the equation for y as a function of x. Sometimes I hate this tablet. Okay, solve for y as a function of x. So we can do that now. So go back to this. Solve for y. So that means the square root of y is equal to 2 plus e to the x. So that means that y is 2 plus e to the x squared. Now I think it says differentiate this explicitly. Is that right? Confirm that the two results are consistent by expressing the derivative in part A as a function of x alone. So yes, that means to differentiate this explicitly. So y prime, which is dy dx, is equal to, how does the chain rule work here?
2 times 2 plus e to the square root of x.
Not to the square root of x, but just to the x.
Yeah.
To the first power times the derivative of the inside, which is just e to the x. So this becomes, distribute the 2, distribute the e. This becomes 4e to the x plus 2e to the 2x. Yeah. Now let's show that this is exactly the same thing. What is the square root of y? Well, let's go ahead.
You distribute the 2.
Yep, distribute the 2. 4 plus 2e to the x. Then I distribute the e to the x, and I get 4e to the x plus 2e to the 2x.
Okay.
Now, what is the square root of y? Well, it's the square root of this, right?
So it's just 2 plus e.
It's 2 plus e to the x. So what I'm left here is 2 times 2 plus e to the x times e to the x, and we've already seen that that becomes this exactly. So that's the implicit derivative right here. It is definitely equal to the explicit once you know that y is a function of x. So they are indeed the same. Check. Number 9.
Even though it wasn't.
Number 9, we've got x to the third power plus xy minus 2x equals 1. So first we find the implicit derivative. So what's the derivative of x cubed?
3x squared.
Now we encounter a product. So first times the derivative of the second, x dy dx, plus second times the derivative of the first, and this part is not a product, so this is minus 2, equals what?
0.
Now we solve for dy dx, so we get all other terms to the other side, so this is 2 minus y minus 3x squared equals x dy dx. So now all I do is I just divide everything by x, and I say that dy dx is equal to 2 minus y minus 3x squared all over x. And that's part A.
And then so do explicit.
Now let's find the explicit. So we have to solve for y here. So we add 2x over, and we subtract x cubed and divide by x. So y, as a function of x, is 1 plus 2x minus x cubed all over x. That's y as a function of x. So this is, right here, David, we would call this the explicit.
Sorry.
That's okay. We would call that the explicit. Did you find Mickey?
I didn't know, so I cleaned up what I saw.
Okay.
There was quite a bit over there underneath there,
He
so I
had
pulled
some,
that.
he had some
thing out.
poo.
Yeah, so I cleaned that out and mopped it all and stuff. And
Thank you.
so we're gonna
Alright.
get some more strips and stuff.
All right, so Carrie, we've now got y as a function of x, so let's differentiate this. So dy dx is, what rule are we going to use? Quotient rule, low d high. So x times 2 minus 3x squared minus high. Now careful now, d low is tough. 1 all over x squared. Okay, let's start distributing, because we're mad distributors in here.
2x minus 3x
Yeah, 2x minus 3x cubed
minus 1
minus 1 minus 2x, so the 2x goes away,
plus
plus x cubed all over x squared. Now let's, what we can do here, let's see here. So that's what we get. So we eventually get, yep, that's right. So we eventually get, make sure I write this correctly. That's a negative, right? So I get, I want to put the positive first, x cubed, oh wait, x cubed and negative 3x, is that a 3x squared?
no,
Yes. Okay, so that becomes negative 2x cubed minus 1 all over x squared. Is that it? Okay. So now, if you substitute y in here, if you replace this y with this, let's do that, but I'm going to have to trust in your notes because I have to erase what I've got on the screen because I don't have enough real estate. So, does everyone have this written down? Okay, so let's go ahead and replace it. 2 minus y, what was y?
1 plus 2x minus 3x squared.
And then,
Oh,
what here? Excuse me.
minus 3x squared.
Minus 3x squared all over x. Okay, so what we do, McKenna, is we play a common denominator game. So I make this 2x over x, 3x cubed over x. And now I've got a common denominator in the top. So now, 2x minus 1 minus 2x, so do you see that this goes with this? And now I have negative 1, this is a
Plus 3x
plus 3x squared,
squared. Minus 3x cubed.
all over, and do you see that this becomes x squared down here?
Yes. Which is what we had.
Which is what we had before.
Wasn't that? I thought it was.
Unless I did something wrong.
That was negative 2x cubed.
What derivative did we get? When we
got
did-
negative 2x cubed minus 1 over x squared.
Something
All right. What was the what was y as a function of x?
1 plus 2x minus x cubed over x.
1 plus 2x minus x cubed all over x. And that was y.
Yeah.
So low d high. So x2 minus 3x squared minus high d low all over low. So 2x, that goes away. Negative 3x cubed, positive x. All right, what's the original equation again? Because we want to make sure we get this right. They are the same.
Wait, the original though.
Yeah, the original equation.
X cubed plus xy
minus 2x.
equals 1.
All right, so let's solve for y again, just to be on the safe side. So I add 2x over, 1 plus 2x minus x cubed, and I divide by this x, so all over x. Let's simplify this just a little bit. Maybe it'll make it nicer. So x to the negative 1 plus 2 minus x squared. Can I do that? That shouldn't.
I get the x to the negative 1 because that puts it in the denominator.
That shouldn't throw you because I have 3 terms in the numerator, so they're all divided by x.
Oh, okay.
Oh,
That
okay.
makes sense.
So this would be easier to differentiate here. So that means that dy dx is equal to negative 1 x to the negative 2. That goes away, minus 2x. Now I get this together. So this is negative 1 over x squared minus 2x. Get your common denominators here. So this is negative 1 minus 2x cubed all over x squared by getting common
Where did you get that
denominators.
x to 3?
Common denominators. I need to get
Oh.
an x squared here. So I multiply by x squared top and bottom. So I finally get that.
Yeah,
Okay.
that's what we got last time.
Now let's differentiate this bad boy. Okay, so this is 3x squared plus x dy dx plus y minus 2 equals 0. Solve for dy dx, so add the 2 over here. So 2 minus y minus 3x squared all over x equals dy dx. Now let's substitute the y back in, so I'll get 2 minus parenthesis x to the negative 1 plus 2 minus x squared minus 3x squared. Distribute the negative. This goes away with that. That becomes positive, so that's negative 2x squared. And this becomes, there's my 1 over x, all over x. So now I get a common denominator carry, so I turn this into x cubed over x. Now I can bring this together, and so I'm going to get the same thing right here when I bring those together. 1 minus 2x cubed all over x squared. There we go. When in doubt, do it all again. You wouldn't believe how many times that turns out to be true in math. All right, what's next?
Can you do 20?
Can I do 20? Sure. Can you? No, I'm teasing you. I'm teasing you. Okay, this is a good question. So, here's how you can make your life easier, McKenna. And we all like it when life is easy. We like it very much. The quotient rule has a tendency to make life complicated. So to avoid the complication, what we do is we multiply all our denominators away. So this becomes xy cubed equals 1 plus y to the 4th power times 1 plus secant y. I don't like the way that's written. I'll rewrite that. Looks nasty. Mathematics needs to be beautiful. There we go. Okay, so xy cubed is equal to that. So now let's go ahead and find dy dx. Now just realize, Carrie, that this right here is a product.
Yeah.
So we're going to use the product rule. Okay? This right here is also a product. Okay? First times the derivative of the second. So this is 3xy squared dy dx. Plus second times the derivative of the first, that's just y cubed. Does that make sense? First times the derivative of the second, so that's 3y squared dy dx. So it becomes this, 3xy squared dy dx. Plus second times the derivative of the first, but that's just 1, so it's y squared, y cubed. Now again, this is a product, so it's first times the derivative of the second. So 1 plus y to the 4th power. The derivative of 1 plus secant, well, the derivative of secant is secant tangent dy dx. Secant y, tangent y, dy dx. Plus second times the derivative of the first. What's the derivative of 1 plus y to the 4th?
4y to the third.
dy
Dy dx. Yes.
Yeah, no,
Why?
Yeah, I just said that because it's ended right. I don't know why.
You don't know
Why?
why?
Did the why is the dy dx?
Oh, okay. Well, then our problem's more serious than I thought. This is the whole point of the lesson. Y is a function of x, but I don't know what the function is. That's what makes it implicit. That's what the word implicit means. Implicit means it's not directly expressed.
Right.
However, there is a derivative to this thing. We're assuming it's differentiable, by the way. That's an assumption. So if I'm going to write this here, take d dx of this. No.
So the derivative of y
Is dy dx.
Okay, so whenever
This is also implicit. Do I have an equation here? No. It's not directly expressed as a function of x. That's the whole point. So if I take d dx of y squared,
it's 2y.
okay, 2y, and then by the chain rule, the derivative of y, which is that.
So if we have a y, we use that.
Because what is y a function of?
X.
X. And we're taking the derivative with respect to x. Do we know what y is explicitly? No. We don't. We don't know what y is explicitly. Right? So that means when we take the derivative of y, the best thing we get is dy dx.
Because we don't know what else
We don't know what else
it is.
it is. It's dy dx,
Okay.
which is the same thing, by the way, as y prime, which is the same thing as f prime of x. It just turns out that this is the notation we like. Because if I put a y prime in there, it might look like a y to the first, right? I want to avoid that. So I need a notation that lets me know that that is a differential of y with respect to x, or a derivative, not a differential. All right, well, you're going to have to tell me what I had on the board because I just erased it.
You had 1 plus y to the 4th power.
Well, start from the beginning.
So it's got 3x.
3x
You had 3x.
y squared dy dx
Plus y
Plus
cubed
1 to
equals
1 plus y to the 4th power.
secant y tangent y dy dx
Plus 1 plus secant y times 4y to the 3rd power dy.
Yes. Do you see where the dy dx is coming from now? Okay? Well, the only thing to do to solve for dy dx here is to get all of your dy dx's on one side and all of your non-dy dx's on the other side, and this is the only term that's not dy dx right here. So what I'm going to do, McKenna, is I'm going to subtract this guy to the other side and then divide by everything. So that means that dy dx is equal to, get ready, y cubed all divided by 1 plus y to the 4th power secant y. Why is it positive? No.
You divide it.
No, I subtracted this guy to this side because all my dy dx's are over here.
But then divide that over there.
Minus 3xy squared. There we go. You have to solve for dy dx. So to solve for dy dx, I subtract this term here to the other side. Thank you.
Why would you subtract the wouldn't you have to divide it?
Well, first I have to get all the dy dx terms together right here. This,
Oh, okay.
and this. Bring it over here, and then I factor out a dy dx everywhere.
Oh, we could divide that.
And then I divide by what's left.
Oh, okay.
It's too cumbersome to do all that at once, or to write all that out. So that's why I went straight to this.
Can we do that when we take tests for this then?
Well, yeah, so long as you're correct. Right? You can definitely do that, so long as you're correct. So there's my dy dx, right there. Hey, find d2y dx2, right? So let's go for 23. X cubed y cubed minus 4. Equals 0. So let's find the first derivative implicitly. So this is a product. So that means that this becomes 3x cubed y squared, what?
Wouldn't it go
First times the derivative of the second.
dy dx?
Oh,
I don't
okay.
understand.
Sorry. Yeah,
Oh, no. Okay, it's done. Because we break it down.
I was
Alright,
doing
first-
I was doing the other one and I was like, what? Okay.
dy dx
Yep.
plus
3x squared y cubed.
equals 0, right? Okay. What I have to do next is I have to go ahead and figure out what dy dx is. So let's go ahead and do that. The way that I do that, Carrie, is I subtract this to the other side. I subtract 3x squared y cubed, and I'm going to divide by 3x cubed y squared. So what that's going to give me is that's going to give me that dy dx equals the 3's divide away, and so I'm going to be left with negative y over x.
Oh.
But do you see that?
So that's
Yep.
implicit.
It's still implicit because dy dx is equal to negative what? Negative y over x. And y is a function of x, though we don't directly express it. Now, we could, in this equation, if we solved for y. If we solved for y. But can we always solve for y? No, we can't. We can't. The ones that we are given in the calculus book, usually we can, but in the real world of science, you don't have an equation. You have data, and you have to somehow figure out what the slopes of your tangent lines are using your data. Okay, so this is what we got. Now, we can differentiate this right here, McKenna, directly. So now we take the derivative of this. So what is the derivative of dy dx equals negative y over x? Well, first of all, what's the derivative with respect to x of dy dx?
D2
d2y dx2. equals, now we're going to use the quotient rule.
Okay, so
Low d high,
so 1 negative dy dx.
negative x dy dx, because it's low d high,
Oh, okay.
minus, but the minus becomes a plus because of this minus, high d low, all over low low. Does that make sense? But we already know what dy dx is. It's negative y over x. So when you put a negative y over x in here, you just end up getting y.
Oh, which becomes 0.
No, you get positive y, because this is negative and this is negative. So you're going to finally end up with 2y over x squared.
So then how do you find, that's your final answer?
Implicitly, yes, that's my final answer.
So what do we, we have to go back up and,
Now we'd have to, if we're going to do things explicitly, which I don't know if the instructions called for,
no,
it just said find by implicit differentiation. But if we were, we'd add 4, y cubed is equal to 4 over x cubed, and then we'd take the cubed root. So y is equal to the cubed root of 4 over x. And now we can substitute that explicitly here and know what the derivative, the first derivative is explicitly. And then we can substitute that in here and then know what the second derivative is explicitly. Does that make sense? Yes, no?
sort of. We do 11 just for kicks.
For laughs and giggles? Sure.
Slash for better.
X squared plus y squared equals 100. All right, let's take the derivative. What's the derivative of this guy?
2x.
Now, technically, David, it's 2x dx dx because you're taking the derivative of x with respect to x. Technically. But what is dx dx? Well, it's 1.
Okay.
Now, this is plus what? 2y dy dx, yes, equals 0. Now I subtract this over, divide by that, I end up with dy dx equals negative x over y. And that right there, McKenna, is the slope of the tangent line at every ordered pair, x and y, for the circle. This is a unit, not a unit circle, but x squared plus y squared equals 100 is a circle centered at the origin with a radius of 10.
Okay, so then we solve for y in terms of x.
So then we can solve for y in terms of x. So y would equal plus or minus the square root of 100 minus x squared. Now please understand that y is not a function. It's a relation because we have both the plus and the minus root. So it doesn't pass the vertical line test.
So we put that back into the dy dx we found.
This would equal negative x over plus and minus the square root of 100 minus x squared. But the negative here would do this, McKenna. It would become x over minus plus square root of 100 minus x squared. There is a difference, a very slight difference. Overall, there's no difference. But in the very slight sense, what it does is the negative would make the positive negative, and the negative would make the negative positive. So it switches the two around.
So isn't it the same as x over minus plus and minus x?
No. No, you can't take the square root of a difference and take each part individually. That's a no.
Oh, because it's a factor.
If you had a product, David, if it was 100 times x squared, then you could do that.
That's your final answer.
That is the derivative of the tangent line at every single point x now, because now it's explicit.
So wait, how do we write the answer? We have two different things we found. How do we show,
Well, this right here, this is the answer because they wanted you to use implicit differentiation. right? That was the instruction.
Yeah.
Find dy dx by implicit differentiation. Nothing about solving for y as a function of x. So your answer is dy dx equals negative x over y.
Okay.
Let's take a hop, skip, and a jump over to number 27. 27 is also a circle, right?
Yeah.
What's the radius of that circle? 1. What's the center?
0.
0, 0. X squared plus y squared equals 1. So 2x plus 2y dy dx equals 0. We're just kind of left with the same thing, aren't we? Dy dx equals negative x over y, right? All right, well, let's look at the instructions here. It says, find the slope of the tangent line to the curve at the given points in 2 ways. First, by solving for y in terms of x and differentiating, and then by implicit differentiation. Well, let's just do implicit differentiation first, because we've already got it, by the way. So this is the ordered pair 1 over the square root of 2, comma 1 over the square root of 2. So if I plug that in here, I end up with negative 1 over the square root of 2 over 1 over the square root of 2, but that's just negative 1. So that means that the slope of the tangent line at this ordered pair is negative 1. So if I drew a picture, here's my circle, Carrie, of radius 1. And here's the ordered pair, 1 over square root of 2, 1 over square root of 2. The tangent line goes like this, so that has a slope of negative 1. Yes? Okay. What happens when I plug in the other one? What's the other ordered pair?
It's just 1 over square root of 2, negative 1 over square root.
Right. So this one's negative.
So it was just 1.
So if I plug that in, that will become positive 1 because this one's negative. And if I graph this out, my unit circle, there's my unit circle. Where's this ordered pair located here? Which quadrant is that in? Quadrant 3. That's down here. And the slope of the tangent line goes like this.
Why would it be on 3 if one's positive and one's negative?
Ask me that again.
Why would it be on quadrant 3 if x is positive and y is negative?
Because that is what it means to be in quadrant 3. X is, not quadrant 3, I'm sorry, you're right. You're right. It's quadrant 4. Thank you. Brain not here today. Do. And that makes sense. That's a positive sloped line, right? You can agree with me on that? Yeah. Thank you, Carrie. And there she is, in all her glory. All right, number 41. Find the values of a and b for the curve x squared y plus a y squared equals b if the point 1, 1 is on the graph and the tangent line 1, 1 has the equation 4x plus 3y equals 7. Okay, so we know that 1, 1 is on the graph, right? So what we do is we plug in 1, 1, and I know that 1 squared times 1 plus a 1 squared equals b. So that means that 1 plus a equals b. I now know that 1 plus a equals b. All because the ordered pair is on the graph. I also know that the tangent line at 1, 1 has the following equation. So that means that I differentiate. So now let's take the implicit derivative. This is a product. So
It's x squared dy dx.
Plus 2xy plus 2ay dy dx equals 0. Now it's time to solve for dy dx. So this becomes x squared plus 2ay dy dx equals negative 2xy. So dy dx equals negative 2xy all over x squared plus 2ay. But what is the interpretation of dy dx? What's the interpretation of dy dx? How do I interpret it? What is it? What is dy dx? It's the slope of the tangent line. So what we do is we go back to this equation here, 4x plus 3y equals 7. Let's solve for y. Y equals negative 4/3 x plus 7/3. What's the slope of that line? Negative 4/3, and that's going to be at 1, 1. So all I have to do is plug in 1, 1 right here, and I'll get negative 2 over 1 plus 2a, and this is the slope of the tangent line, right? By plugging in 1, 1. Well, that's supposed to equal what? Negative 4/3. So this is negative 4/3. Now you solve for a, that's exactly right. Multiply 3 up here, so that's negative 6. Multiply 1 plus 2a up here, so that's negative 4 minus 8a. So negative 6 equals negative 4 minus 8a. Add 4 over, so this is negative 2 equals negative 8a. Divide by negative 8, a has to equal 1/4. 1 1/4 or 5/4. Okay. So is it important to know how to interpret dy dx? Oh yeah. Now this part right here, this is nothing more than algebra 1, right? Solve for y. Remember, this is the tangent line at what ordered pair? 1, 1. So that's why this all agrees. That's why it all matches. By plugging in 1, 1 here, I can agree with this slope equaling negative 4/3. Plug in any ordered pair, I can't necessarily say that. Okay? Find equations for two lines through the origin that are tangent to the curve x squared minus 4x plus y squared plus 3. Find equations for two lines. So I have to take the derivative. So the derivative is 2x minus 4 Now I solve for dy dx. Would you agree with me that dy dx equals 4 minus 2x all over 2y? I can divide out the 2's and just say 2 minus x over y, make it a little bit simpler.
And then we solve for y.
Now let's solve for y. So
negative x squared plus 4x minus 3 take square root of that.
So let's see, 4x minus 3 minus x squared. Square root of that means that y equals plus and minus 4x minus 3 minus x squared. Find equations for two lines through the origin that are tangent to the curve. Through the origin, huh? Which means that the two lines go through the origin. So next thing I'm going to do here, Carrie, is I'm going to take that equation. Let's graph it out.
What does it mean through the origin?
Means that the two tangent lines themselves go through 0, 0.
Okay.
All right, this is what we're looking at.
It's a circle.
Yeah, or it's an oval or an ellipse right here. So we need a tangent line that goes through 0, 0. So one tangent line, if you follow the cursor, is going to go this way, and the other tangent line is going to go this way.
Okay, that makes sense.
You see that?
Yeah.
Now, in order to do this, we need a point on the oval. That will make sense. Okay, we need a point on the oval.
The radius is 1.
The radius doesn't really apply here. Let's see. Well, wait a minute. Okay, I guess this is a circle, isn't it? Because it's one to the left, one to the right. Yeah, you're right. I'm sorry. That's a circle. I don't know why it doesn't look like one, though. It doesn't really look very circle-ish, does it?
No, it doesn't. It looks smushed.
It does. Okay, so we know that the line is going to go through 0, 0. We've got the slope, by the way, of the tangent line. So let's see if we can find an ordered pair on this thing that works real quick. Let's see, there's my dy dx. Now I can't just let x equals 0 and y equals 0 here because that's undefined, right? Okay. We need to find an ordered pair that goes through this right here. And by the way, if I let x equal 1, y equals 0, it solves the equation. Unfortunately, this right here isn't so good, is it? If I let y equal 0. So here's what I'm going to do, McKenna. I'm going to look at the picture, and can we agree that, let's see, I want the tangent line to touch and go through here. So we want to point here. Oops, go back out. We want to point somewhere along here that comes down, it's tangent, and it comes down through 0, 0, and it comes up and it only touches once. That's what we want. So let's do this for just a second. We know that the equation of the tangent line is y minus y1 equals m times x minus x1, right? And we know that the tangent line has to go through the slope. So that means that y1 is 0 and x1 is 0. It has to go through the origin, right? So that means y equals m x. We want an equation like that.
Don't we have M?
We do have m, but the problem is that we have m in terms of x's and y's and not a real number. So this will go through the origin right here, but right now our m is a function of x and y, and we need a real number in order to make this work.
Can you put that as negative x squared 4 times negative x, well, positive x times 1?
Can I do what now?
Can we factor that?
Can we factor that?
Yeah, the equation that's in the
Well, we could do this. We could do this, right? If y is equal to mx, right? Could I replace this with mx?
yeah.
So I could say mx equals plus and minus the square root of 4x minus 3 minus x squared, right? Now I can square both sides, and I could say m squared x squared equals 4x minus 3 minus x squared.
So how do we?
I'm just playing an algebraic game right now, David. I'm just saying, okay, let's substitute y with mx and see if I can solve for x here, figure out where that works. It would be nice if I had a real number. Do we have a nice way of figuring out a real number that will work? Something that'll go through.
Isn't 2 comma 1? Isn't that 1?
2 comma 1 is this point right here.
Yeah.
But the problem is that if I connect it here,
Oh, okay.
go straight down, it'll be secant. It'll go through the circle twice.
Oh, okay.
And I want this thing to be tangent.
How about?
So I could use 2 comma 1, but that would be a secant line. That'll be a good thinker. 1.5. 1.5.
Yeah.
We can definitely try it. So let's try that. So let's plug that in then. If that means that the slope here is 2 minus 1.5 over whatever you get when you plug 1.5 into this, right? All right. So plug 1.5 into this for me. Tell me what you get. Give me the positive. 4 times 1.5 minus 3 minus 1.5 squared, and then square root that whole thing. .866.
0, 2, 5, 4, 0, 3, 8.
2540, like that.
There's a 0 between the 6 and the 2.
0 here. I think that's the square root of 0.866. That's the square root of 3 over 2. Calculate for me the square root of 3 over 2 real quick. Not square root of 3 divided by square root of 2, but just square root of 3 divided by the number 2.
Oh, okay. Yep.
Yep, so this is the square root of 3 over 2. So that means if I plug it in here, I get 2 minus 1.5 over square root of 3 over 2. 2 minus 1.5 is 0.5, which is 1/2. Reciprocate, I get 1 over the square root of 3. So now let's go ahead and graph the equation y equals 1 over the square root of 3x. It works. That's tangent. And the other one is y equals negative 1 divided by the square root of 3x. So there's two tangent lines that both go through 0, 0 that are tangent to the circle. Okay? Do you feel a little bit more comfortable?
Baby steps.
So what you need to do is you need to go back and do those ones you couldn't do before. Now, this one right here says find dy dt in terms of x, y, and dx dt. What that means is that you're assuming that both x's and y's are functions of t. So with whatever time we have left, I'm going to go ahead and start you on this one.
Remember 26 to 40, all right?
Mm-hmm. Okay, so for this one, you're assuming that x is a function of time and that y is a function of time. And you're taking dx dt and dy dt. So this first one becomes 3x squared y squared dx dt plus 2x cubed y dy dt plus dy dt equals 0. I use the product rule, right? X cubed times y squared, first times the derivative of the second, and actually I did it reversed, didn't I?
Yeah.
I'm sorry. So it actually, this should be first. 2x cubed y dy dt should be first, and then plus 3x squared y squared dx dt equals 0. And it's assuming that our differentiable function, hint, the derivative both differentiate both sides of the given equation with respect to t. So that part's done. That's now been done.
Oh, so we just leave it like that? You don't
Yep.
try it?
Find dx dt and dy dt.
So now I have to.
Oh, it says find dy dt in terms of x, y, and dx dt. So now I have to solve for dy dt. So I subtract this guy to the other side. So that means that 2x cubed y plus 1 dy dt equals 3x squared y squared dx dt. Well, then I divide by all that, right?
It was negative 2, right?
2x cubed, yep, negative y plus 1. There we go. So that's dy dt in terms of x, y, and dx dt.
But where did the other dy dt go?
I factored it out. That's where I got the 2x cubed y plus 1 from.
So homework's from 26 to 40 even?
Homework is from 26 through 40, all those, and then 41 through 43 all.